didn't see you there.
Sorry.
Welcome to Miss Bala's physics class. I'm Josh, Ian, and Shane, and we'll explain Newton's third law of motion.
Today we're going to be showing you 3 demonstrations on how Newton's law applies to a tug of war, a rocket launch, and a cannonball.
A force is a push or a pull that acts upon an object as a result of its interaction with another object. Forces result from interactions. According to Isaac Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. There are 2 forces resulting from this interaction, a force on the chair and a force on your body. These 2 forces are called action and reaction forces and are the subject of Newton's third law of motion. Formally stated, Newton's third law is, for every action, there is an equal and opposite reaction. And in every interaction, there is a pair of forces acting on the 2 interacting objects.
For this example, Ian and Shane are pulling on 2 different spring scales. Here we see that both of the spring scales move to the same measurement, indicating that they are both pulling with an equal and opposite force to each other. The forces are parallel to each other and are heading in the opposite direction. With the same magnitude and the same force, they cancel each other out, and thus the center point of the 2 spring scales does not move. Whoa! Now that was a fast launch. Let's see that in slow motion. So, the rocket moves upward because of a force equal and opposite to the gas escaping the bottom of the rocket. This is the principle to how all rockets launch. The exhaust flow, pushed downward towards the ground, produces a force equal and opposite that pushes the rest of the rocket upward. This reaction is what causes the motion of the rocket upward. The motion of the gas molecules downward, resulting in the force of the rocket upward, is called thrust. The cannon and the cannonball are very representative of Newton's third law of motion. When the cannon fires this ball, the cannon pushes on the ball and the cannonball pushes back on the cannon with the equal force. This is very representative of Newton's third law of motion because the force exerted on the ball by the cannon is met with an equal and opposite force in the opposite direction that pushes the cannon back. The cannonball moves with much greater acceleration than the cannon because the cannonball's mass is much less than the mass of the cannon. This relates back to Newton's second law of motion. The recoil from the motion of the cannon backwards is a result of the equal and opposite force of the ball. We now hope that you understand Newton's third law of motion. Thank you for watching. Have a great time in Miss Bala's physics class this year.
I'm Casey.